This is a very difficult question. It is not a high priority for most people. There's a lot of other good stuff in this hard module that is much more definitive that you can get right by using formulas and memorization. Here, we're going to use a lot of memorization, but you need to know a lot of things about quadratics and parabolas to be able to get a question like this right confidently. So let's just go one piece at a time. Let me try to show it to you as I see it. First, I recognize that the equation that they give me to start is the standard form of the parabola. Okay, so this is the version that we use when we're trying to use quadratic formula or most of the other formulas that are associated with quadratics. This is the form that normally has ax squared plus bx plus c. So we can see that it mostly follows that. The difference is the b is a 4, so they've given us one of the values, but the a and the c we don't know, and we're clearly trying to figure that out based on those Roman numerals. But let's keep reading before we kind of dive into that piece. They also tell us the graph of this equation is a parabola that opens upward. So that's important, okay? That relates to the a. The a term in the standard form tells us the direction of the parabola. So really what this is telling us is since it opens upward, we know that a is greater than 0. So just to kind of refresh your memory, if we have a positive a, it's going to open up like a smile. And if we have a negative a, it's going to open like a frown. So it's going to open downward. So in this case, we need the smile. So that means that a is greater than 0. Now, does that mean that it has to be greater than or equal to 1? That's a little bit more narrow. So I don't know yet. But it seems like these are kind of slightly different rules. And maybe we are going to have a reason it can or cannot be one way or the other. Let's take a look. Well, actually, let me say this also. The c term, just to kind of complete this, gives us the y-intercept of the parabola. So that's going to be important later. So continuing, they're now talking about the vertex. The vertex is at the point hk. That's the normal way that we talk about vertex for like generic formulas where h and k are constants. They do tell us that k is less than 0, meaning that our vertex is going to be below the x-axis. Okay, so it's going to be below the x-axis. I'll draw that in a second. Then they give us this weird piece, which I'm going to highlight. F of negative 9 equals f of 3. For many of you, that was just like gibberish. Like, it has to do with points, but what does it mean? Well, basically, since we know that parabolas are symmetrical, we're being told where the middle of this parabola is. So I'm going to draw a quick version of this. This is not necessarily accurate, so you got to kind of be okay with that. So it's a little bit lopsided, right? So we have 3 as one of the x's and negative 9 as the other. Here's my x-axis, here's my y-axis. So when they tell us that f of negative 9 and f of 3 are the same, they're basically saying that those points have the same y-coordinate. So it's something kind of like this, where I'm going to just kind of arbitrarily pick these 2 points. They have the same y, but their x's are different, negative 9 and 3. And now I can connect these dots, because I know that parabolas have the same basic shape, right? They're going to come down, and there's going to be a vertex, and they're going to come back up. And it's symmetrical. My picture might not be great, but I'm trying my best to make it so it's symmetrical. Because the middle point, that vertex, that's what I care about. So in this case, that vertex does follow the instruction I was given, that it's below the x-axis. I drew the y-intercept below the x-axis too, but just be careful, that might not be the case. For now, all I care about is, where is this middle? The fact that I know where the negative 9 and the 3 are is going to tell me where the middle of this thing is. Basically, we have a distance now. These 2 points, negative 9 and 3, are 12 apart, right? Negative 9 to 0 is 9, another 3 is 12. So halfway is where the vertex is going to be, meaning on either side, we're going to have 6 as our distance to get to the vertex. And now we can figure out, okay, negative 9 plus 6 would get us to negative 3, and 3 minus 6 would also get us to negative 3. So this is indisputable. This highlighted fact now tells us that the x-coordinate, the h of the vertex, is negative 3. So that's really important. I don't know the k. I know it's negative, but I don't know what it is exactly. And I'll never know, actually. But I can use the x-coordinate to my advantage. There's another formula that I know for parabolas that's going to come in handy here. It is that the x-coordinate of the vertex is equal to negative b over 2a. Now, sometimes this is just described as the axis of symmetry formula. It's used to find the kind of straight vertical line that splits a parabola in two, that divides it symmetrically. And so that's kind of, again, what we're doing here. We're using the symmetry of a parabola to help us. But because I know this formula, I can solve for a. I have all the pieces I need. The x-coordinate we just said is -3. The b is given to us in the equation, right? That's the one part they gave us. So that's 4, so -4, and then 2 times a. So now it's just a matter of solving for a. There's only one variable. So -6a is equal to -4. Divide by -6. -4 over -6 is 2/3. So wow, that's really helpful because that just disproved number 2. 2/3 is not greater than or equal to 1. So really helpful here. So that at least gets us down to, let's get rid of B, that gets rid of C. So now we're at a 50-50 shot. And here's where maybe you can just kind of think about this conceptually. Is there really anything forcing us to make the C positive or negative? No. What we can do here, this is so messy. I'm going to show you the algebra way. We can plug points into equations. Plug points into equations. Because we have part of a point, right? The vertex. We have an equation, at least part of it, so we can plug things in. So we can do f of -3 is equal to, now we just said that a is 2/3. So x is -3 squared plus 4 times -3 plus c. So let's just simplify this. It's gonna be still a little confusing. -3 squared is 9. 9 times 2/3, so this is 9. The 9 will cancel with the 3, become another 3, so this should be 6 minus 12 plus c. So that is -6 plus c. Now, we don't know the y-coordinate that goes with this point, but we do know that it has to be less than 0, right? That's what they said here. So I can turn this into an inequality instead of an actual equation where I can say, okay, the y-coordinate is less than 0. So -6 plus c represents the y-coordinate. So that is less than 0. And that lets us add the 6 to both sides to get that c is less than 6. Now, again, that's different from what I'm told up here. C is less than 6 includes some numbers that would not be included by the Roman numeral. C is less than 0. So what does that mean? Well, I guess that C could be 2, meaning the y-intercept could be 2. And I could test this out. So at this point, I'm telling you, we have proven this wrong and D is the answer. But you might not be convinced, and so that's good because we have a calculator which can help us. So what I've done here is I've entered the equation as it was given, right? The only change I made is that I made it y equals instead of f of x. It's the same thing. It doesn't graph it because there's too many missing parts, right? The a is missing, the c is missing, the calculator doesn't know what to do. But it gives us this option to add a slider. And if we hit this all button, it's going to start graphing it because it's going to make up numbers for a and c. Basically, the calculator arithmetizes for us if we use this feature. But what I want to do is I want to kind of start to narrow my options, right? So I could play with the a, and I could kind of maybe from the start even have kind of played with this and seen like, okay, what could happen if I change the a? Well, now it opens down, so a can't be -2, all that kind of stuff. But let's kind of give it what we know. If I tap this here, it's going to let me actually pick a value for a. So I'm going to do 2/3, which we figured out what it is. And notice if I do that, look at my vertex, right? It has an x-coordinate of -3, and it has a y-coordinate of -5, which is less than 0, less than the x-axis. So this all satisfies my conclusions. But notice the c is 1. The c is positive, which wouldn't satisfy this Roman numeral. So this is giving me a parabola that fixes or solves or checks off all the boxes that the question gave me with all the little rules that it gave me. This one is a parabola that satisfies all those rules, and yet it does not satisfy the two Roman numerals, right? So we're proving those Roman numerals wrong. And I can adjust the c. I can move it to negative if I want. We can see that it's now does work, right? It has negative c's. It has a negative y-intercept. The vertex is still the same, -3 there. You can kind of see it moving up and down. Or we can move it above. And let's see what happens wherever c is now 3.44, right? We said c has to be less than 6. What happens if we make c 6? Oop, c, come on. There we go. C is 6. Look at that vertex. Now the vertex is at 0, right? Y is 0. So that would not satisfy the k being less than 0, the y coordinate being less than 0. So that's why that inequality before was so helpful, is it kind of gave us all the range of possibilities. So the y-intercept, the c, it can go up, but only to a certain point before now it crosses the x-axis, and now we have a positive value for the y-coordinate of the vertex, and that would break the rules. This is a lot. This is a lot to think about. I mean, I'm mostly just using this as a way to show you a bunch of things to memorize about parabolas, a way to kind of solve all the vocabulary stuff that they throw at you, but also as a way to kind of experiment with the calculator and use it as a tool to help you in these confusing situations. Because a lot of the confusing situations are like this, where we have these kind of like hypothetical values. Maybe we solve for them, maybe we don't, but the calculator lets you play with it and kind of just see different things. Because for most of us, being able to see this parabola in our mind's eye or even on a scrap paper, just kind of based on the wording, is very difficult. I struggle with that. So it's very helpful to me that I have a calculator built into the test that is so flexible that lets me just, with a move of my finger, change what this thing looks like. This is really great. This is much better than any graphing calculator, physical graphing calculator I've ever owned. So I think this is a really good change, and hopefully you can sneak a couple of those hard questions across the finish line using the features of the calculator. It certainly would have given me the confidence to get this right if I were taking this test. I hope this helped. It's a messy question, but I hope my video helped.